Given f of x equals 1/3 sine x on x being between pi over 2 and negative pi over 2, find its inverse, and then sketch the inverse, and then state the domain and range. Well, this is going to be great. Well, all right, let's find the inverse. So whenever I find the inverse, I like to pretend that f of x is y, and so that's going to equal 1/3 sine x, right? Step number one when finding the inverse is swap the x and the y, so 1/3 sine y. Okay, multiply both sides by 3, and that will allow the 1/3 attached to the sine to go away. Okay, so you are gone, and now we have 3x equals sine y. And if you're like, whoa, buddy, whoa, that's a lot of space for you to leave right there. I know, because the next step is to get rid of sine. And the way you're going to get rid of sine is you're going to inverse sine both sides, like that. So you inverse sine both sides. That crosses out. Okay, that gives us y equal, I'm just, flipping sides, inverse sine of 3x. So inverse sine of 3x. And then I need to write it out as f inverse of x equals the inverse sine of 3x. Now I'm going to sketch this from the point of view of f. Okay, I'm not going to act as if I have the inverse sine memorized. I kind of do, but I don't really. So let's kind of remember what sine, 1/3 sine of x looks like really quickly. Okay, really quickly. This is f of x. Okay, this peaks out at 1/3, bottoms out at negative 1/3. Okay, starts at 0, 0. It goes up and hits that 1/3 at half a pi, which so happens to be the end of my domain, which means it goes down here. Let's get rid of that. Let's try that again. It's going to go down here and bottom out, okay, at negative half a pi. So a little more curve, and a little more curve. There we go. All right, that's okay. Now, when I look at this from a table point of view, okay, that's my graph. We know that an inverse is going to be the reflection of the y equals x, but let's look at it this way also. Let's look at it from a table point of view. Here's going to be my x and f of x. My key points are at negative pi over 2, I'm at negative 1/3. At 0, I'm at 0, and at positive pi over 2, I'm at positive 1/3. Now, the table of an inverse is flipped. So its inverse is going to be negative 1/3, negative pi over 2. Flip them. 0 flipped with 0 is 0, 0. And 1/3 is going to be my x value, and pi over 2 is going to be my y value. So now when I graph this, okay, when I graph this, I'm going to peak out at pi over 2, and I'm going to bottom out at negative pi over 2 down here. I'm going to go to the right 1/3 and to the left negative 1/3. And when I graph this, I have that 0, 0. I have that dot right there poorly drawn, and that dot right there poorly drawn. And this is going to be the action we come up with. Okay, so that is the graph of its inverse. Similar, very similar, but if you can kind of see, if I were to draw like a perfect diagonal there, this would kind of flip and that would kind of flip, and then that's kind of what's happening there. All right, now what does that do with the domain and the range? Well, here was the domain of my original problem, which means my range is going to be the domain of my original problem. Now, when I graphed my original problem, let me just write that out. Let me just write it out. When I graphed my original problem, it peaked out at 1/3 and bottomed out at negative 1/3. Okay, it peaked out at 1/3. So my range for regular f of x was negative 1/3 to regular 1/3, which means my domain of the inverse is going to be the range of the original. Like that. Okay, so I approached this problem slightly differently, where instead of trying to memorize what the inverse looks like, I found the inverse and then graphed the inverse using information about the original. Well, wasn't that fun? It was.